Example number 19, finding a triple transformation of a tabular function. Given table 15 for the function f of x, we want to create a table of values for the function g of x, which is equal to 2 times f of 3 times x plus 1. So we need to observe what's going on here. Okay, first things first, there are 3 steps to this transformation, and we will work from the inside out, starting with the horizontal transformations f of 3 times x, which is a horizontal compression of 1 over 3, which means that we need to multiply each x value by 1/3. So f of 3x tells us that we have a horizontal compression by multiplying each x by 1 over 3. So we're going to take 1/3 and multiply by its inputs. 1/3 times 6 gives us 2. 1/3 times 12 gives us 4. 1/3 times 18 gives us 6. And 1/3 times 24 gives us 8. And the outputs remain the same for the first step. Now, the second step tells us that we need to multiply everything by 2. So, looking now to the vertical transformations, we start with a vertical stretch, which will multiply the output values by 2. So we apply this to the previous transfer. So we're taking 2 and multiplying by the output. So the vertical stretch means you're multiplying all the outputs by 2. So the inputs now stay as 2, 4, 6, and 8. And now we're going to multiply the outputs, which are 10, 14, 15 by 2. So 2 times 10 gives us 20, 2 times 14 gives us 28, 2 times 15 gives us 30, and 2 times 17 gives us 34. So now we have 2, 20, 4, 28, 6, 30, and then 8, 34. Okay, now the third step is that we can apply the vertical shift, which we will add 1 to all the output values. So that means we're taking the entire function, which is the output, and then adding 1, which is a vertical shift by adding 1 to all the new outputs. So our inputs stay the same as 2, 4, 6, and 8. And then for 20, 28, 30, and 34, we're going to add 1 to each of them. So 20 plus 1 gives us 21, 28 plus 1 gives us 29, 30 plus 1 gives us 31, and 34 plus 1 gives us 35. So therefore, we have 2, 21, 4, 29, 6, 31, 8, and then 35.